This is lesson 6.4, solving systems of equations using substitution, and this is part 2. Okay, so our objective is I will solve systems of equations using substitution. Okay, yesterday we learned about that. We did a couple of practice problems today. We're going to do another practice problem and then the real-world application. So our essential question is, how can you use algebra to solve a system of linear equations when a system cannot be solved by graphing? Okay, remember when to use substitution, right? So the essential question says, when can a system be solved when you don't use graphing, right? So when would you use substitution? When to use substitution. All right, and that is when you have, you have your two equations in your system, y equals x plus 2, and then 2y plus 3x equals 14. You would use substitution when, first of all, you see we have an equation right there that's not in y equals mx plus b form, so it would be hard to graph unless we put it in y equals mx plus b form. So if you have an equation is not in y equals mx plus b form, that's when you would use substitution. But also, and at the same time, see over here, this first equation, y equals x plus 2, we have the y, we have an isolated variable y, okay, meaning the y is by itself. That's when we would also use substitution, when you have an equation that is not in y equals mx plus b form. And then also you have another equation where you have an isolated variable. In this case, the y is isolated, it's by itself. All right, and you have an equation with an isolated variable. Okay. Let's look at example number 1. Solve the following system of linear equations by using substitution. Remember, we're going to use substitution because we can't really, we're not going to graph this equation right here. It's not in y equals mx plus b form. And then our equation up here in our system of equations, we have an isolated variable, y equals something. So we could use that to substitute. Remember, you substitute in the isolated variable. So you have y equals x plus 2, and then 2y plus 3x equals 14. Since y equals x plus 2, here's our isolated variable. Let's find the y in the second equation, and we're going to plug in the value of what y is right there. Because remember, when you use substitution, you want to solve for one variable at a time. So let's recopy the second equation. All right, and then we're going to substitute wherever we see a y, since y equals x plus 2, wherever we see a y, we're going to plug in, what do you think? You guessed it, x plus 2. So we have 2 times y, which we know from our equation, y equals x plus 2, so we're going to plug in x plus 2 for y. We're going to replace it. And then recopy the rest of the equation, plus 3x equals 14. Okay. Now, to further solve this, see how now we got rid of the y. We don't have x's and y's anymore. We're solving for x first because we substituted in for y. So now we have an equation And first thing we want to do is we want to distribute this 2 to both things inside the parentheses. Right? Because it's 2 times the quantity x plus 2. So it'd be 2x when you multiply. 2 times x is 2x, and then plus 2 times 2, which is 4. That's how I got 2x plus 4, because I distributed the 2 to everything inside the parentheses. And then plus 3x equals 14. Okay? Now we have 2 terms that look alike. We have a 2x and we have a plus, keeping the sign in front of the number, a plus a 3x. So we can combine those. They both have x's. So if we have 2 x's and we add another 3 x's, think about how many x's you would have. You would have 5 x's, so it's 5x. Plus 4, we still have 4 on this side of the equation. And then equals 14. All right, let's further solve. This is a 2-step equation. We want to get x by itself, so let's bring this 4 over, subtract 4 from both sides to cancel these 4's out. Now we're left with 5x equals, well, we have over on this side of the equation, 14 minus 4 is 10. To further solve, you divide by 5 on both sides to get rid of the 5 and get the x by itself. And x equals 2, right? Because this is a divided by sign, a fraction sign is, so it's 10 divided by 5 is 2. Now, we know that x equals 2, but remember, when you solve a system, you need to find the value of both variables. And see, in our system, we have y's and we have x's. So we need to get the value of the x and the y. We know that x equals 2. So remember, to figure out what the other variable is, look back at both equations, and we need to find out what y equals. Well, wait a second. We know that y equals x plus 2. So let's write that down. Let's recopy that equation. Y equals x plus 2. And we just found out that x equals 2. So let's plug that in for x, right? See, we have y equals x plus 2. We just found out that x equals 2. So let's plug it in. Y equals 2 plus 2, which means that y equals 4. So our ordered pair for this system of equations, the solution is the ordered pair 2, 4. Meaning, if you were to graph these equations on a graph, the point of intersection would be at 2, 4. That's the solution. Okay, now what you want to do is you want to try the got it number 1, and then watch the video to make sure that you got that correct. Make sure you try it first before you watch the video.